My name's Derek Yu. I'm the CEO of PureStake. We're the main primary contributor to the project Moonbeam. But what I wanted to talk to you today about was about cross-chain architectures, cross-chain use cases. This is something that we work a lot with teams on Moonbeam around different kinds of cross-chain use cases, and there's really is a lot of interesting things happening at a very fast rate right now in terms of taking advantage of new technologies, taking advantage of creating new architectures, new cross-chain architectures. And so really that's what I wanted to talk to you guys about today a bit. So just starting out, when we talk about cross-chain, we've been working in this area for some years now. It's really not a question of if, but just how quickly this is going to happen. And I'll point you guys to, you may have seen recently that there was an important governance vote in the Uniswap community, right? So Uni token holders were voting on what system to use to pass messages from Ethereum mainnet to BNB chain. And this proved to be a contentious vote, right? So there was different factions within the Uni community that were voting for different technologies. There was a faction that wanted LayerZero to be the technology that was used. There was another group of people that wanted Wormhole to be used. In fact, it is Wormhole that ended up winning that vote. What was in question though was what technology was going to be used to pass governance messages from Ethereum mainnet that the Uni token holders voted on to this remote chain. And so you're starting to see that this kind of thinking about, okay, I have a protocol, it's deployed on multiple chains, how do I connect these different deployments together? How do I create a single governance domain, as an example, on a multi-chain deployment? So this is the kind of things that are happening now when you look at multi-chain, look at cross-chain scenarios and the kinds of problems people are dealing with. So just to give a little bit of context as to the point, how I'm, the point of view that I have and how I'm getting information about these different cross-chain scenarios. Moonbeam is a layer 1 blockchain that specifically focuses on cross-chain and interoperability use cases. It's built as a parachain. It's part of the Polkadot ecosystem. So it has some built-in communications capabilities with other chains that are within the Polkadot ecosystem. They're called parachains. But it also has a number of other tools and integrations around it that are designed to facilitate cross-chain development. Some of those are general message passing protocols. You see some of them here, like protocols like Axelar, Hyperlane, Wormhole, LayerZero. There's a number of different development teams building protocols on Moonbeam that are leveraging one or more of those new message passing systems. These systems are all designed to facilitate sending of messages back and forth between different blockchains. And so it's really, this is an area that there's quite a lot of interesting development going on right now. The other thing about Moonbeam is it is EVM compatible, so a lot of the standard Ethereum developer tools are in and around the platform, things like Etherscan, Chainlink price feeds, and so on, right? There's a whole suite of tools that one expects these days in an EVM compatible platform. And so just before diving into some of the architectures, I wanted to talk a little bit about what is it that motivates developers to create cross-chain applications? What is it that that are the unlocks? And I think the key three unlocks from my mind that I'm seeing across teams that are building these solutions are, one is definitely around market, right? So historically you chose one chain and you're limited in scope to servicing the users and assets in that one chain. That's not good enough these days, right? People want to be able to service users and access services across many chains. So it's this idea of going cross-chain to increase your market share is an important one. But at the same time, there's an opportunity for improved efficiency. So when you have a deployment that's an isolated island on each chain, that's much worse than having a single system that is connecting multiple chains together at the same time. And so that's another theme that we're seeing. And I think in the end, the key unlock that is possible using these cross-chain techniques is around the user experience. You can hide away a lot of the infrastructural complexity from the user and create simpler user experiences when you use cross-chain technologies. And I want to just dive in quickly to talk about an example to kind of make this a little bit more tangible and illustrate what I'm talking about. So we'll take the example of a team that is building in the Moonbeam ecosystem. They're going to their mainnet launch towards the end of March. So they're just about to launch. The protocol is called Prime Protocol. It's in the DeFi space. And the way it works is this. It's a hub and spoke architecture. So there's a hub on Moonbeam that's kind of the center of the system, but then there's a number of different spokes to the system where there's remote contract deployments on a bunch of chains, right? So on Ethereum mainnet, Avalanche, Polygon, you have these like remote smart contracts on each of these chains. And the remote smart contracts are connected back to the hub using these cross-chain messaging like systems. And so the interesting thing that this allows Prime to do is that it behaves like one system even though it's deployed across many chains. And let me illustrate with an example of how it works. So it's a lending and borrowing protocol. Users, like you can have a user on Avalanche that would make a deposit on Avalanche into the local contract on Avalanche. So they're interacting with a local Avalanche contract. A message is sent back to the hub saying, hey, this user deposited this much AVAX into the contract. The AVAX doesn't move. It stays like local on Avalanche, but the information about the deposit moves to the center. So now in the center, you have basically this this state across all the chains of like what the balances are, right? What the borrows, what the lends are. And so that same user now can go to Ethereum mainnet, let's say, and they can say like, I want to borrow now against my deposit, right? It'll query back to the hub on Moonbeam using cross-chain messaging, and it says, this user has this much AVAX, so let's allow them to borrow ETH against the AVAX. And in that scenario, the assets never move. There's no bridging operations, right? There's just information about the state is basically moved to the center, and there's almost like a database at the center that's keeping track of what's happening across all of the chains. And so there's like a bunch of like interesting things that are possible once you have an architecture like this, right? So one is you can cross-leverage, right? Any deposit on any one chain, you can leverage on any other chain. From a UX perspective, right? Like the user is interacting just with something local, right? They don't have to like switch or like do bridging actions to like get to the protocol, right? They're interacting with something local. And yeah, there definitely is like an efficiency gain like from this kind of architecture. I think of it as much like the real world where you might have an HQ and then you have a branch office location in multiple different cities, but they're all connected into the same organization. And so that's a good example of the kind of architecture we're talking about. Just to give another example in a different domain, if the last example was DeFi, here's an example from the gaming space. So there's a gaming project on Moonbeam called Exiled Racers. They, as well, are using a hub and spoke architecture, using cross-chain messaging systems to connect all of these components together. In their case, it's a racing game. So you have pilots, ships, different boosters as NFTs, right, that you purchase that you can use to race. And there's different race tracks, basically, where you race your ships, basically, against other people. Now, the way it works is Moonbeam is kind of the hub. There's a set of racetracks on Moonbeam, but there's also racetracks on a number of other chains. And so you can move your NFTs from Moonbeam to race on other tracks if you want. But the data, like about like what happened in the races, is aggregated back to Moonbeam. So you have like a kind of a universal view of the performance of what happened across all the different chains. And then, there's kind of interesting things they're doing. So for example, you see this Zeitgeist chain below. So Zeitgeist is another parachain on Polkadot. They have a prediction market. And so what the integration there is okay, if the data about the races is all aggregating back to Moonbeam, now people can use a prediction market on Zeitgeist to make a wager on the outcome of a race. So you can wager on a race, the race happens, and then the outcome of the race, the user can then claim winnings if they guess correctly in the Zeitgeist prediction market. And so all of these things are made possible by cross-chain integrations, using messaging to share data, but not moving tokens, right? You're not that kind of moving tokens like in the traditional bridging sense. So I think it's quite interesting. And here you can see that they're going to be able to get new users by going to all these different chains, right, and offering something unique on each chain. So just to talk a little bit about, obviously all these things are great. There's great new capabilities, but there are challenges. This is a new kind of development, right? And most development historically has been centered around one chain. And so now when you're moving into this multi-chain environment, a lot of the dev tools, for example, are not designed to deal with these multi-chain scenarios or messaging systems. So that's one challenge. I would say that a lot of the teams that are putting cross-chain integrations at the center of their architectures, they face this challenge of it's kind of scary to go all in with one, right? So if you choose just one system like Axelar, let's say, what if Axelar's down? Well, then you could be in big trouble. In the case of Prime, it's a lending and borrowing protocol, right, where prices could be changing, and users could be subject to liquidations. And so a lot of these teams are then saying, okay, I need to learn at least two. In their case, it's Axelar and Wormhole. And so then if one is down, maybe they can still send messages out the other way. So it's kind of like redundancy in the system. And so this is like one of the areas that I think you're going to see a lot of movement in creating kind of more redundant techniques around using cross-chain messaging. The other thing is around security. So I'd say on the security side, a lot of security thinking is centered around threats from the same virtual machine you're in. So if you're on Ethereum mainnet, you're worried about other contracts and other calls happening inside that VM. Once you network your contracts so that they can receive messages from the outside, you have this new class of network threats, right? When you receive a message, you have to check, okay, who sent this message? Was that an authorized person? Is this like an invalid message? Or someone trying to game the system? So there's a new class of security threats that a lot of developers are tackling now as they're moving cross-chain with these native techniques. And so I wanted to, after going to these examples, just wanted to pull back a little bit. I mean, part of what I wanted to share with you guys today was thoughts on where things are going, right? And thoughts on how I see things playing out. And I'll share with you one way of thinking that, a kind of a mental model that I use, and I'm trying to reason about what's going to happen in the future. I'm kind of a bit of a technology history buff, so I like the history of technology. And in particular, I think a lot about the history of compute, right? So like how computers evolved, and use that to try to reason a little bit about how Web3 is going to evolve. And so in my thinking, if you look at the history of compute, you started off with unnetworked standalone computers. They were very scarce resources, so then you had all these features to allow multiple people to use them at the same time, right? You got time sharing, right? Everyone could have their own terminal, but you're sharing one computer behind the scene. That seems to me very much like where we came from, right? That's like Ethereum, right? Something like that. And I think we're now entering into this era called kind of the 80s, right? Where you have multiple multi-user systems. They're starting to be networked together, but it's proprietary. A lot of the networking technologies are proprietary. There's not a lot of standards right now around how interactions across chains are supposed to happen. Even these messaging systems I talked about, generally speaking, they allow you to deliver byte payloads, right? It's like byte arrays that you're passing to your remote contract. And I expect, though, a lot more higher level protocols to develop. There would be the messaging standards that are used inside of these messaging payloads. Just like happened in with computing, right? Where you had different kinds of protocols that were built that had more features on top of just the raw networking capability itself. But so if we're in this era now of this kind of networked multi-user systems, like these EVM chains that people are connecting together, I fully think that things will continue to evolve in the same way compute did, right? More servers, more blockchains, right? It's going to be ever easier to produce blockchains, EVM blockchains, or could be blockchains centered around other technology stacks like Cosmos SDK or Substrate. And I start to see the teams that are pushing the edge are thinking about multi-blockchain architectures, like we just talked about, where you may have specialized blockchains that are performing certain functions like data storage or transaction processing, much like internet architectures evolved. And yeah, I think that moving to a more cloud-like experience, just like happened in Web 2, is likely to happen here, where ever easier to create these specialized blockchains, ever easier for the developer to consume those resources. I expect that to be the way that things evolve. The old saying is that history, things rhyme with history. They don't repeat, but they rhyme. There's some patterns that are similar. And if I look out at the landscape now, there's these connectivity protocols. But when you talk about compute, right, how do you get block space for your application? There are certain areas where I see the similar patterns emerging. So up at the top, we are part of the Polkadot ecosystem. That's one ecosystem. It is a network set of block space, let's call it, or resources. Same thing in Cosmos. Has been around for quite some time. But there are new environments, for example, like Avalanche. With their subnets, I think they're recently rebranded to hyperchains. So they have this idea that you can launch your own application-specific blockchain to get block space for your application. Same thing with Polygon has their supernets that are coming out. That's an EVM compatible, it's called sidechain or kind of application-specific chain. And all of them are thinking about how to network these things. How can you pass messages in between these different application-specific blockchains that are being launched? So that's a set of things that where I see similar patterns emerging. And then of course you have a number of app-specific layer 2 rollups on mainnet. For example, like the OP stack, right? Like it's making it easier to deploy application-specific rollups. And I don't think there's, it's not clear which way things are going to go, right? There's multiple different options, but these style approaches are definitely in keeping with this idea that it's going to be ever cheaper and ever easier for developers to get dedicated block space for their applications. Just like it became ever easier for developers to get compute resources from the cloud, right, for their application. And I think that when I think about the way things are going to evolve, I myself was involved in a Web 2 with a Web 2 startup. Sorry about that. I guess I shouldn't stand forward of the line here. The architecture supporting our mobile application had thousands of servers, basically, right? So this was using multiple cloud environments. There was different platform as a service features being used out of AWS, out of Google Cloud. A lot of different specialized systems. But in the end, the end user experience being presented was a very simple mobile experience. And so in Web3, we're obviously not there yet, but I do feel that things will evolve in a similar path, right? There's going to be multiple different specialized kinds of Web3 infrastructure services, right, that developers will be able to use. But in the end, the key will be to abstract that away so that the user doesn't need to know about all of the different components that they're interacting with. Being able to offer a simpler user experience to users. That's the direction that I see. But it might be that when you're in the future, when you're interacting with a Web3 application, there may be dozens, there may be 100 blockchains behind the scenes that are servicing those requests. And I think that's this kind of simultaneous evolution into specialized compute resources that are easier for developers to access, but simultaneously user experiences that require less and less knowledge of the users, less knowledge about the infrastructure they're interacting with. That's the direction that I see things moving in. And so, if anyone wants to learn more, these are these cross-chain use cases are something that at Moonbeam we're specializing in. So if anyone in the audience is interested in learning more about developing cross-chain solutions, different messaging protocols, we support a bunch of them on Moonbeam. There's a whole bunch of tutorials and other documentation. I encourage you guys to either join our community, come to our Discord. We have a very active DevRel group that can help you learn about these different techniques. And so, yeah, thanks very much.